Welcome to this video tutorial. In this video, we will talk about gaze controls in Unity, specifically for VR applications for Android. For gaze controls, there's 3 projects that can help you get started. First one is Gaze UI for Canvas. It's available for free on the Asset Store. As the name implies, it is mostly designed to work with UI objects in Unity, so canvases. Second, there's VR Samples by Unity. It's also available for free. Lastly, there's GoogleVR SDK for Unity. Current version is 1.150. Let's have a look at these in Unity. The VR Samples already have a radial reticle that we can use, and it works with these interfaces here. It's important to note that those interfaces are meshes with mesh colliders attached. As we will see, it is a difference between raycasting against meshes versus UI elements, and that's important for us. Now this is fairly limited here, and it also requires us to actually press down buttons to interact with those items. So instead, I wanted to have a automatic way without pressing any buttons to just hover over an item and then press this item after a short amount of time. I'll show you what this looks like. Here in this scene, this is the room that comes with the GoogleVR SDK, but I'm heavily modified it. You can see a little reticle here, and the moment I hover over an object, so this is a normal object with a mesh collider, you can see the progress bar, and then it disappears. In this case, it's because I clicked the object. It doesn't do anything when I click it, but it definitely works. You can also see up here the text changes as I hover over this item, so there's on-gaze enter and exit events. And if I wait long enough, we have an on-gaze complete. And here we have an UI element. There's a normal button. You can see I can hover over the item and it behaves normally by changing color as it highlights. You can also wait, and it presses the button at the end and an object disappears. One other thing is we can use normals to adapt the reticle to the surface of the object. And that is functionality that comes from those different projects. So I basically mix and match a couple of things and then scrap most of it to implement stuff on my own. But I definitely want to give credit to those 3 projects just because I took bits and pieces from them. Now, I'll make the code and the parts of this project available for free. I cannot give away things that are like from the GoogleVR SDK, like the instant preview, which I just used. As you were able to see, I moved my phone around and controlled the scene view here. I can only recommend using GoogleVR instant preview. And if you have any questions about how to set this up and how to use GoogleVR and Android development more broadly, I'll link a video below where I went through all this setup. Now, let me go back to the actual GoogleVR room so that you can see the difference of what this looked like. I have to disable editor emulator and just play the scene. Again, there's GoogleVR instant preview. And here you see the reticle here, and it expands as we move over this object. Now there's several limitations. The first one is that this reticle is actually a mesh. Now the other reticle that you just saw before is a UI element, and that's a big advantage. This mesh here is created in runtime, and I didn't really find it very useful because in order to have it as a progress bar, we would have to then look at a shader that colors this object, whereas a UI element is much easier to create for such a progress bar, a radial progress bar. Now the other thing is that there's no sort of clicking or any events implemented here. It's really just hovering over an item and then nothing happens. So that's a big difference. So there's quite a bit of work to do if we wanted to use this. Now, one thing that you have to keep in mind is what kind of interactions do you want to support with your project? Because in the other scene, I basically kicked out most of the functionality of GoogleVR so that things like the hand controllers, if you want to support Google Daydream, wouldn't work anymore. So you really have to think, how much do you have to rebuild, or how much do you want to integrate with one of the existing solutions? Now, to be fair, I think if you're starting a fairly large project or something where you really want to learn a lot, then I would definitely suggest implementing everything from scratch, because you learn a lot. You learn a lot about all the raycasting that's going on and all the physics and so on. So trying to implement or trying to integrate with those existing solutions, whether that's Google VR or whether that's those VR samples by Unity, it's fairly painful because they're fairly complex, sometimes unnecessarily complex. So in order to really understand what's going on, it's best to implement things from scratch. Now, having said that, let's have a look back over to the scene. And let's decompose what this looks like. So let's go through all the objects one by one. We start with the event system. We definitely need an event system, but I got rid of all the input modules. We don't need any input modules. The only thing that this implementation needs is an event system. Now, if you want to support any button presses or anything like that, then obviously you need an input module, the standard input module. Now, Google VR Instant Preview is invaluable. It's absolutely great. You can also just copy and paste this prefab and put it in any of the other projects, and it works. Now, it's a bit fickle because of the connection sometimes, and sometimes I have to restart my computer, but it is absolutely great. So definitely make sure you understand how to use it, and especially because Unity Remote doesn't work at all for me. So I think a lot of people are frustrated with it. So Google VR Instant Preview is definitely great. All right, so we have a canvas here. And one thing to say is that if we want to interact with canvases with raycasts, we absolutely need a graphic raycaster. So any canvas that you want to interact with needs a graphic raycaster. Graphic raycaster has the option to select different layers. So you would only interact with the objects that are on certain layers. So you could put a button or something on a separate layer. But that's what you need. So if you have 10 canvases in your scene, you need 10 graphic raycasters. Keep in mind, there's also a canvas here on the player object. It also has a graphic raycaster. And this canvas here contains the reticle, but we'll go through that in a moment. Let's go back to this other canvas. We have a button on this canvas, and this is the button we just interacted with. So it has a normal button script, so the color change and so on really works like the normal button. The on-click event also works. But here we have a script called VR target item, and that's what we use. That's what we have to put on every single object that we want to interact with. And exposes the gaze enter event, the gaze exit event, and a completion event. But if it's a UI element, we don't have to necessarily use these. We could instead use the on-click event here. It really depends on what you want to implement, whether you need some on gaze enter or on gaze exit. Okay. Now the room is pretty simple. That just came with the project. Nothing special about it. Name for the light. The treasure is those two objects here. And I removed all the scripts that originally came on these objects. And instead, I just put the VR target item script on here and implemented some very easy gaze enter, gaze exit completion events. Nothing special here. It's pretty easy, pretty simple. And in order to interact with any meshes in your scene that contain either a mesh collider or a box collider or any other collider, you need a physics raycaster in your scene. So you only need one physics raycaster, and this ideally is on your camera or somewhere where you can find it. And again, graphics raycasters on each canvas. All right, let's look through the rest of the player object here. So the root object here is empty. Then there's the camera, normal flare layer audio listener, physics raycaster. Again, you can select the different layers you want to raycast against. And then we have two scripts, the VR gaze controller and the radial reticle. And we go through these scripts in a moment. Next, there is an empty parent object. And then we have a canvas which contains the rest of our reticle. It's a world space canvas, it's fairly small. Let's zoom in a little. That's all there is, this little object here. And then there's a little dot in the middle. This is our center of the reticle. Next, we have an image. It's the circle, which is from the VR samples project. And the image type is filled. fill method is set to radial 360, which allows us to take the slider here and to fill up the sprite as a radial progress bar. Very handy. And then this background here is this semi-transparent version of this circle, and it's just the image type simple. Now what we can do is we can basically connect our progress to this variable fill amount. All right, so there's 3 pieces we have to look at. There's the VR gaze controller, radial reticle, and the VR target item. The VR gaze controller is just a number of just debug things. Then this is variables for our event system, and then the targets that we're looking at. Now, in update, we're calling gaze raycast. So once a frame, we will raycast into our scene. We use a debug ray, and then we set up our raycast. Now, the raycast is a event system raycast all. And this is really important because we want to support raycasting against UI elements and meshes. Now, if you use a physics raycast, which is probably the more common raycast, then you can only raycast against meshes that have colliders. And it will not work with UI elements unless, like in the VR sample scene from Unity, you actually create your UI elements with meshes and put colliders on them. Then you can use a physics raycast to make this slightly easier. But I had to change that. I took the code from this VR samples project, and I scrapped most of it because I changed it to raycast all to support both. Now, the definition, I think, in the documentation from Unity for raycast all is that it casts rays of all supported base raycast types. And the question then is, what is supported? Well, supported is whatever raycasters you have in your scene. So that means we have our physics raycaster for the meshes and colliders on those meshes, and we have our graphic raycasters. So this is why our raycast all, our event system raycast all, is leveraging those raycasters and using them. That's why this works. All right, then we get some results back, which is raycast results. We loop through those results, check whether there's a VR target item on any of them, and the first one we hit, we simply return. We set it as the current target, and then we set our reticle to the position of that result, of that target object. Now, if we loop through all of these and don't find anything, then there is no target found. Next, we just check whether the current target is similar to whatever happened last frame, so that we can compare. And so if the current target is not the same as the previous target, so previous frame, then we found a new target, which means our reticle is shown, so the progress bar is shown, and we call gaze enter. And if there was a previous target that still exists, then we also call gaze exit for the previous target. Now, if our target this frame is the same as last frame, then we're hovering because we're over the same item, which means our radial progress bar is being progressed, so it's going to be filling up over time. And lastly, if we didn't hit any target, but there is still a previous target that exists, then we call gaze exit for it, and then we reset everything. And lastly, complete selection is exactly what it says. If our progress bar is full, then we complete everything and call gaze complete. Okay, our reticle, it's pretty straightforward. Just a couple of variables, whether we're using normals, and we're storing an original scale and rotation so that we can reset everything if needed, enabling, disabling our radial image, our progress bar, setting the position, which is we use this when we don't find any targets, so that's the default position and distance of our reticle. And this is setting the position when we actually hit something, so we're going to set it wherever our raycast result is, so wherever we hit the target. Those last 3 functions are for progressing our radial bar. So we have a timer, and we normalize that by the duration that we have, so that we set, in this case, I think the default is 2 seconds. And once our timer exceeds our duration, then we're done, and we can reset everything. Lastly, our VR target item has two different things. Firstly, it has our 3 events for gaze enter, gaze exit, and completion. And also, in order to support UI elements, we have selectable and iSubmit handler. Now, if our item is a selectable or implements the iSubmit handler interface, then we call those. So those are onPointer enter, onPointer exit, and onSubmit. So that's usually what UI elements do. But if they're not available, then we simply use our gaze enter, gaze exit, and completion events. And those are all Unity events. So what this looks like is that you can just press the little plus icon here and then drag and drop certain things in here that you want to happen. Now, obviously, you can change this stuff around if you're only using one or the other, only UI elements, or if you want to do both at the same time, then just change the script to your liking. I will post everything under this video here, and you can use those scripts to your liking. Just be aware that some parts of it are from the other projects, and I just modified them. All right. This is pretty much it. So if I wanted to add a new object here, I would just, for example, add a cube. Cube already comes with a collider, box collider. I add VR target item, and I can now just add events here for gaze, enter, exit. So like enter gaze, I want the object to disappear. And that's all there is. And it's gone. Okay. Now, if you have any questions, just post in the comments below. Let me know. One thing to say is that this implementation right now only supports buttons or anything that you can hover over, but it doesn't update sliders or like scroll rect, for example, to scroll down a scroll rect. So if you're interested in that, have a look at Gaze UI for Canvas. There's some code in there that helps you with sliders. And I just didn't get around to that yet. Please let me know if you have any problems with it, and thanks for watching this. If it was helpful in any way, subscribe to the channel, and I'll see you next time.